Okay, now that we have x equal 1/2, now that's not an inflection point. That's a possible inflection point. In order to find if this is an inflection point, we have to use the second derivative sign test that I taught you. It's like the first derivative sign test, but use the second derivative. And what we're testing here is the point 1/2. Okay, so what do we use? Well, I'm going to take a 0 to the left, and I'm going to take a 1 to the right. And let me rewrite the second derivative now, because we are going to use that. So the second derivative, as we have it over here, is 2 minus 4x over x plus 1 to the 4th. All right, so I'm going to take the second derivative at 0. It's going to be 2 minus 4 times 0. 0 plus 1 to the 4th. So this is going to be 2 over 1. So what happens to f double prime 0? It's greater than 0. Now let's do f double prime 1. That's going to be 2 minus 4 times 1 divided by 1 plus 1 to the 4th. So that's going to be minus 2 over 2 to the 4th, right? So what you're going to get is minus 2 over 16, but I don't care about that. I just care the fact that it's less than 0. Now let's look at what less than 0 means with the second derivative. Well, when I tested this, this would be that this is at a minimum point. And this would test at a maximum point. Now remember what I said, a maximum point is concave down, right? Concavity is below the maximum point. What I said about a minimum point, well, this is a minimum point, this is concave up because the concavity is above the minimum point. So what I'm going to get here basically is this. Since f double prime 0 is greater than 0, we have a minimum point. So we have this guy here. And since f double prime 1 is less than 0, we have a maximum. This is concave up. This is concave down. Now, because there's a change in concavity, means that this is an inflection point. Let me erase these since I have them on there already. And say, since at x equal 1/2, we get a change in concavity of the function, then x equals 1/2 is an inflection point. The last question is does that inflection point represent a point of diminishing returns? Now, so does x equal 1/2 represent a point of diminishing rate of returns of f of x. Pretend f of x is profit. Now, how do we do that? Well, look at what we have here. We go from this to this. Remember what I said? This is a smile. This is a frown. If your rate of returns are diminishing, you think you're happy? No. So whenever I go from a smile to a frown, thus x equals 1/2, yes, is a point of diminishing returns. Now, what happens if this was concave down and that was concave up? I would go from a frown to a smile. That is not a point of diminishing returns, but it still is an inflection point. As long as there's a change in concavity, no matter which way, concave up to concave down, or concave down to concave up, you will have an inflection point. But the only time that inflection point represents a point of diminishing returns is when you go from concave up to concave down on both sides of the inflection point. And so let's see what's going on here. And let's do just a little sketch, but I'm not going to graph this right now. We've been concentrating a lot on this problem. But basically what we see here is if we graph this, is I have a point where I'm going, well, somehow like this. And this point here is x equal 1/2. Notice I'm going up here, and all of a sudden I start to go up and I start to level off. And this is where it starts. So x equal 1/2 is a point of diminishing returns. I go from a smile to a frown. That's the easiest way. All right. Let us finish this by drawing the graph, and then we can go on to something better. We'll do some business problems. And as you can see, I have drawn the graph on your notes. You'll notice from the notes that this is the real graph. You have, let's see, you have x equals 1/2, 1, 2, 3, this is 1/2, and we have 1, 2, 3, 4, and let me get another pen here. I could use the black for this. But we get our horizontal and our vertical. I'm sorry, that's a really bad line. But you know what I'm trying to do. That's a really bad line. Wow. So this is x equals 1/2. This is y equals 1. And the curve looks something like this. Curve looks something like this and like this. Notice here's the change in concavity right here. It should be like this really, but here's the change in concavity. It should have been around 1/2, but I didn't draw it that well. But it does change. It's tough. Well, let me redraw that because that is wrong. So this comes down here, it hits the bottom here, and starts to change in concavity. So there's your inflection point here. Also. All right. Let us go on, and we're going to be talking about optimization. This is section 10.3, optimization. In business. And you can add economics there if you want. So let's take our first example. I'm going to skip the example on 10.31. That's a revenue one. You can go through that by yourself. And I'm going to do what is say example 2 on your notes on page 10.3 2. Okay? So now we have a competitive market. And in a competitive market, we have a revenue equals 50x, and we have a cost function which equals 0.01x squared plus 30x plus 1900. So what do we want to find? Well, we want to find the profit function, and we want to find the max min points. This is very similar to a problem on your take-home test. So this is similar to problem I'm sorry, it's problem number 4 on your in-class test, not your take-home test. So let's go and solve it. Let me erase the top. As I spin around, I think I'm learning how to do a pirouette in this thing. Well, anyway, A, find the profit function. Well, P of X is the revenue minus the cost. Profit function is 50x minus bracket 0.01 x squared plus 30x plus 1900. And this is 50x distribute okay, and this is going to be 20x minus 0.01x squared minus 1900. And that is your profit function. Notice why I drew the brackets, so I can distribute the negative throughout. If you didn't have the bracket, you might be tempted to put a plus 30 here and a plus 1900, and that would be totally wrong. Well, what we will do in our next class, which is on Friday, is take the derivative of this and find the max min points. So I'll see you on Friday, which is the 27th.